Welcome to a preview of MTS, the McFadden Transportation System. It is expected that this system will virtually eliminate your country's addiction to oil. It will revolutionize transportation in your country and probably the world. It will have a major favorable impact on trade imbalance for your country and have substantial positive impacts on your country's economy, employment, and the environment, while fairly minimal infrastructure changes are needed. There are two major problems with battery electric vehicles. One is that the battery capacity is not large enough to power the vehicle for long trips. The second is the long recharge time necessary. And for these reasons, battery electric vehicles will probably never be a major mode of transportation in the United States. And this transportation system eliminates both of these problems. The central components of the system include two parallel electric rails embedded only in limited access expressway lanes. No rails would be included in entrance or exit ramps. And these rails would be embedded flush with the road surface, as we'll see in the next slide, therefore should be 100% compatible with traditional vehicles. This slide shows a diagrammatic cross-sectional view of the electric rails embedded in an expressway lane. And you can see number 1 refers to the electric rails, number 2 refers to the insulation material around the rails. And from this slide you can see that the rails and insulation material are embedded in the roadway, flush with the roadway, so it will not interfere with traditional vehicle traffic at all. Another central component of the system would be the vehicles. The vehicles would be electric with batteries. These vehicles would include automobiles and trucks. They would have two electricity pickup devices that contact the rails upon activation of the system. And activation of the system would also activate automatic steering control, sensors on the vehicle that would help keep the electricity pickup devices in contact with the rails. And one could also activate a cruise control system to control the rate of speed of the vehicle. These electric vehicles would operate and charge simultaneously while on this limited access expressway with this electric rail system. The current range for a battery electric vehicle is probably somewhere around 100 miles. And this system would provide for trips approximately 100 miles to the expressway. And then, of course, you could go an unlimited distance anywhere on an expressway with this system. And then for another 100 miles off this expressway before you would need to recharge or get back on this expressway for recharging. And here's another figure demonstrating what a vehicle on the system would look like traveling down a limited access expressway with the electric rails, number 1 there referring to the electric rails. In number 5 you can see the electricity pickup devices would drop down upon activation and contact these electric rails. These electric vehicles would also have the option for a small gas or diesel generator on the vehicle, and these could be used when one anticipates traveling past the battery distance limit. I would expect that less people would see the need for this option as more expressways have the rail system and technology improves the capacity of batteries. There could be a variety of generator capacities as an option for these vehicles. The lowest capacity would be able to prevent the need for towing in the rare instance that one might actually run out of electricity. A little higher capacity could be capable of powering the vehicle at a slower speed, or perhaps while the vehicle is stopped and charging. And a higher generator capacity could be capable of actually powering the vehicle for normal operation. This system of generators could be set up such that there's a limited number of standard size generators that can easily be installed or removed with standard electrical connections that control the generator and that receive the electricity from the generators, and this should help minimize the repair and maintenance cost of these generators. Some engineer and design efforts would need to be performed, for example, to determine the optimal rail distance separation for automobiles and trucks, and also to help minimize the potential impact on humans, walking, and animals. And the optimal rail design would need to be performed to help minimize interference from weather, for example, snow and rain. Also, efforts to determine the optimal rail design and position on the road to help facilitate smooth travel for these electric vehicles and also for traditionally powered vehicles. Engineering design efforts would also need to be performed to determine the appropriate electricity pickup devices for these vehicles, and the automatic steering control system would need to be designed so the driver can easily turn the steering wheel if desired or if necessary. Also, the location and interval distance for the circuit breakers for the system would need to be determined to help minimize problems due to accidents. While we certainly need to address safety with this system, the rails would only be on limited access expressways, freeways, or existing toll roads due to limited access, in other words, minimal pedestrian contact. Rails would not be on expressway entrances or exits. We could compare this system to a large city's metro rail system, where adults and children are in very close proximity to electric rails at each of the metro stops. And if you think about it, how often are adults or children standing by an expressway, or for that matter, actually crossing an expressway? Very rarely. And these rails would be designed wide apart, perhaps about 5 feet apart, to help minimize the impact on humans and animals if they are in the area. And the system would have short segments with circuit breakers, so if there is an accident, a car or truck across the rails, this would break the circuit breaker. And also for emergency control, if there's an accident or somebody has mechanical problems, a flat tire, or there's humans or animals near the expressway, one could simply call 911 or some other designated number to have the current shut down to that portion of the expressway. And keep in mind that vehicles could continue to operate under battery power in this situation. And the expressway markers with small lights would identify the location so that if there is an incident, an individual could simply look at the expressway markers and know precisely where you are so that the current is shut off in the proper area. And also these expressway markers would have small lights to identify the current status, so an individual could simply look at these lights to know whether the current is on or off in this area of the expressway. I actually expect fewer vehicle traffic accidents due to the automatic steering control, a key component of this electric rail system. The automatic steering control would be designed so that the driver can easily turn the steering wheel if desired or if necessary. And cruise control with sensors to control speed is certainly possible to set up because we already have systems that are capable of detecting if an accident is imminent and applying brakes. And this system eliminates the need for drivers and passengers to sit above 15 to 20 or more gallons of gasoline in current vehicles, which is certainly a risk in an accident or if the vehicle malfunctions. With this system, we'd have fewer trucks transporting 9,000 or more gallons of gasoline. Good fence security is always a good idea, regardless of the system, to help minimize access of humans or animals to these limited access expressways. And of course, we'd need to develop snow plows with vertical insulators on the plow. Certainly a lot of electricity would be required to operate this electric rail system, and preferably this electricity would be provided from renewables such as solar and wind, etc. Solar farms and windmill farms would be spread throughout this expressway system to help minimize energy loss due to resistance from traveling long distances. And keep in mind that the cost of electricity would not be competing with current residential electricity costs. It would be competing with the cost of operating a vehicle with petroleum. And since the cost of electricity in this system is competing with the cost of operating a vehicle with petroleum products, therefore this system should support the cost of renewable electricity sources such as solar, wind, etc. And the charge for the electricity could also include part of the rail installation and maintenance costs and still be substantially lower than operating a vehicle with petroleum products. And let's take a look at the cost associated with implementing a system such as this. The vehicles, the electric motors, the electricity pickup devices, the automatic steering control, all of these would be supported by the automobile and truck manufacturers. And keep in mind that electric motors cost less and have lower maintenance compared to internal combustion engines. Electricity. I believe as soon as we announce what we're willing to pay for renewable sources of electricity and traditional sources, we're going to see a lot of private sector companies pop up all along the expressways to help support this system. The rails, maintenance of the rails, I believe, will be fairly minimal, and I think that most of this cost could be supported by the vehicle electric meters. Installation of the rails, I think part of this could be supported by the vehicle electric meters, but I think initially at least the government may need to get this going and support some of the installation costs associated with these rails. The cost savings for this program, vehicle maintenance, like I said, the electric motors cost less and have lower maintenance compared to internal combustion engines, and also vehicle insurance. Since there will probably be fewer accidents due to the automatic steering control, there will probably be lower insurance rates for these vehicles. Keep in mind that this system does not require any major technology breakthroughs. And technology improvements such as smaller, lighter, lower cost, higher capacity batteries will only improve the MTS system. And also keep in mind that this system actually increases the efficiency of battery electric vehicles, which are already fairly efficient, because batteries are not 100% efficient. This system should be even more successful over time as we develop lighter and higher capacity batteries to extend the range that a vehicle can travel from the expressway. And also, this system would make traveling long distance much easier and much more comfortable due to the automatic steering control, and also no need to stop for petroleum or to recharge batteries. And of course, this system would be 100% compatible as we develop new electricity producing technologies. Direct impacts on the economy and employment would include renewable energy companies such as solar cell, windmill, and geothermal companies, manufacturers, installation, and maintenance. For traditional electric companies, for auto, truck manufacturers and their parts suppliers for products such as electric motors, batteries, electricity pickup devices, and automatic steering control systems. For rail and wire manufacturers, installers, and maintenance. And I believe whichever country leads this effort into this electric rail transportation system provides an advantage for companies within that country to export their products to the rest of the world. And there will also be some direct positive impacts on the economy and employment for the trucking industry, and it will also result in an increase in farmers' income and their land value for windmill farms and solar farms, especially those farms that are within about 50 to 75 miles of all of the expressways. And also keep in mind electric motors have lower maintenance and repair costs compared to internal combustion engines, and this will provide a beneficial impact on the economy. With this system, we'll be converting much of the automotive and truck energy use from oil to electricity. And so this will leave plenty of oil for other industries. This decrease in demand for oil will help keep the price of oil down, and so many other industries will do much better, such as the airline industry, the shipping industry, the cruise industry, the chemical industry, the RV industry, recreational boat industry, the tourism industry, small businesses, and really essentially lower the cost of goods for all companies and consumers. And so the expectations for this transportation system are that it will virtually eliminate the addiction to oil. It will revolutionize transportation in your country and probably the world. It should have a major favorable impact on trade balance for your country and substantial positive impacts on the economy, employment, and environment of your country. And this will all be accomplished with fairly minimal infrastructure changes, considering the tremendous positive impacts on your country. Thank you very much for your time, and if you're interested in contacting me, please feel free to contact me at this email address.